Myself, Dr. Kamal Khan Joshi, Associate Professor in Graphic Era Hill University, Department of Environmental Science. In this lecture, we will discuss about the wastewater treatment methods. So before starting of this topic, first we have to understand the value of our water resources. You know that the 71% of water is available on earth in the form of stagnant water, lakes, ponds, and running water in terms of rivers. Besides this, some water is also available underground water as a aquifers in different depths of lithosphere. Nowadays, it is a very serious issue or a problem that the all water resources have been polluted by the different methods. Some activities are the natural activities and some are the anthropogenic activities which are responsible for the water pollution. So what is the meaning of water pollution? Because the water have a dissolved oxygen, and when the dissolved oxygen become decrease, then the water become pollute. So in this lecture, in the treatment method, the basic objective to treat the water, it means that we will increase the dissolved oxygen into the effluent water. So this one is the basic objective of the wastewater treatment. So there are various practices and the methods which are helpful to reduce the effluent, to reduce the impurities from the water, so that this water can be used by the different purposes. We can use this water after the treatment. We can use this water for a drinking purpose, for a irrigation purpose, and bathing and washing purpose also. So let's start the different methods. So first, the prevention and control method of wastewater or the water pollution. So first one method is the general awareness method. You know, the awareness is the best practices which are very much helpful to reduce the any kind of problems. So in different ways we are awareing to the students from the childhood. If we aware to the students from the childhood how to use the water as well as to stop the water pollution. In addition, there are several practices like the awareness campaigning through the advertisements by the local channels, TV, etc., animation also, and newspaper also. These awareness programs and these awareness slogans are very much helpful to reduce the water pollution. So this one is the first way, or we can say this one is the primary way which are responsible to control the water pollution. Now the second method, this one is the technical treatment methods which are very much helpful to reduce the wastewater. So these technical treatment methods can be divided into two categories, like the primary and secondary treatment. And after the secondary treatment, if we want to use this water for a drinking purpose, we can use the tertiary treatment also. So the primary treatment method, the primary treatment is basically the filtration method. So if we want to pure the water, first we have to purify this water. We have to reduce the impurities, and such types of impurities, they are solid form. So different types of sieves or filters which are very much helpful to reduce the impurities as a primary level. Or in the primary treatment, generally we use the different types of sieves or the filter papers also. And these techniques, the primary treatment techniques, are very much helpful to reduce the 30 to 40% of the BOD. In other terms, we can say that the BOD, biological oxygen demand, it can be reduced by 30 to 40% by the primary treatment method. The suspended particulate methods, it also can be reduced by the primary treatment methods. So these primary methods will be discussed in details in next slide also. So let's we take a basic introduction of the primary and secondary treatment. Now the secondary treatment generally in the secondary treatment generally we use some microbes also, and with the help of these microbes we can reduce the impurities, or in other words we can say we can increase the dissolved oxygen level into the wastewater. So in the secondary method we use generally two types of bacteria. These are the anaerobic bacteria, and next one is the aerobic bacteria, which are very much responsible to reduce the BOD and COD about the 90%. So if we decrease the BOD and COD level about the 90%, obviously it means then we can increase the dissolved oxygen into the water body. If we increase the dissolved oxygen into the water body, it means water is treated now. Now in this slide we will discuss in detail about the primary secondary treatments. Now you can see in this slide, this one is the basic effluent treatment plant. This treatment plant is generally used in some agro industries, and such types of industries generally used to produce the liquid glucose, maltodextrin liquid powder also, liquid and powder also. So these are the agro industries effluent treatment plant. So let's start the how the ETP effluent treatment plant is working, or in this figure we will discuss about the primary and secondary treatment also. So let us start. Here you can see this one is a inlet point. Here the effluent is enter into the first chamber, and this one is the collection unit. And before the entering of this collection unit, this effluent is enter into the filter unit. So filter, this one is indicating the primary treatment. So most of the impurities in terms of solid they can remove through these different types of filters. Now this effluent is collected into the collection unit or the collection pit, and it is stay at least about the 24 hours. Within a 24 hours, this effluent is generally accumulate as a normal temperature or the atmospheric temperature, and after that, and most of the fumes they may remove from this collection unit. After that, this effluent sent into the second chamber. This one is the pH unit. Before starting of any secondary treatment, first we maintain the pH of this effluent, because this industrial effluent may be a highly acidic or may be a basic. So we can use some urea and sodium hydroxide to maintain the pH in this pH unit chamber. So if we get a pH about 6 or 9 pH between this range, so this effluent can be sent into the secondary chamber. This one is known as a USAB, upper sludge anaerobic blanket. So the first primary treatment is complete between two units, like the collection filter unit, collection pit, and the pH unit. After that, this effluent sent into the USAB chamber. This USAB chamber is a anaerobic treatment plant where we use some anaerobic bacteria. These bacteria generally decompose all dead and decay matter which is present available in this effluent. Why we use this anaerobic treatment in first primary phase or first phase? Because this effluent have a very poor dissolved oxygen, or the dissolved oxygen is completely absent in this unit. So these anaerobic bacteria, they have a very special quality. These bacteria, in absence of oxygen, they decompose all dead and decay matter which is present in this effluent. After this treatment, these anaerobic bacteria, they produce some methane gas. This one is the biogas, and after their treatment they also produce a sludge which is indicating in this like in black color. So this sludge is have a good organic material, and this sludge is also used for organic fertilizer also. After this anaerobic treatment, this effluent again sent into the huge aeration tank. Here in the aeration tank some anaerobic bacteria is already present. So these aerobic bacteria, they treat again this effluent because in this effluent have a few amount of dissolved oxygen. So these aerobic bacteria, they again decompose this effluent material and convert into a little bit, or you can say in a fresh water also. After this treatment, these chambers, USFB chambers, it comes under the secondary treatment plant. So after this treatment, if we check the dissolved oxygen in this water body or BOD level, so we can say that about the 90%, 80 to 90%, the BOD level has been removed. BOD, biological oxygen, may be removed from this after this treatment, or the dissolved oxygen is available in about the 80 to 90% of dissolved oxygen available in this effluent also. Now this water is known as a wastewater, not a effluent, because the effluent have a very poor dissolved oxygen, or you can say the absent of dissolved oxygen. Now after this secondary treatment, this water is known as a wastewater. Now you can see here is another chamber. This one is a centrifuge filtration. If the centrifuge filtration is have a pulley, they are functioning just like a moving pulley. So the effluent is enter into the centrifuge filtration, and all the suspended particles which are present in this wastewater, they are stored in the center and they settle down in the bottom of this tank. And after finally you get a final outlet which have a rich amount of dissolved oxygen. Now this water can be used for the irrigation purposes also. So this one is a basic, or in a simple manner I have discussed here how the water is treatment, how the effluent is treated by the different primary and secondary treatment. If this outlet water, if we want to change this water quality, if we want this water for a drinking purpose, so we have to add some chemicals so that all pathogens they can remove from this water. So generally we use chlorine to reduce the pathogens from the wastewater. So the quantity we can add like 1.2 to 1.5 mg per liter chlorine can be used in this wastewater so that the pathogens can be removed from this wastewater. In addition, nowadays we are using the ozonization techniques, in which we use the ozone gas as well as the UV radiation process also to remove the pathogens from this wastewater. So in this way you can see that after the primary and secondary treatment, the most of the effluent they are treated by this primary and secondary treatment methods. Now the another method is also known as the bioremediation method. Generally the bioremediation process which is suitable for the treatment of wastewater with the help of microbes, because the microbes have a natural quality to decompose all dead and decay methods. So to know the value of this, the quality of microbes, they have the specific quality of some microbes. Now the bioremediation, now the second method is the bioremediation techniques. In this bioremediation techniques, generally we use some microbes, and you know that the microbes have a nature to reduce to decompose all dead and decay methods. But some microbes have good qualities to reduce all dead and decay methods. So scientifically we in laboratory we collect such bacteria and we develop such type of bacteria for the bioremediation practices. Some bacteria like the Geobacter species and Disulphotomaculum species and Disulfovibrio species, and some Clostridium species are the very much responsible for the bioremediation practices also. Generally, you can see in this picture, like these microbes, here you can see that this one is the contamination water or the contaminant. Then we add some microbes. So these microbes, they function on the function on this waste material or the contaminated water. They decompose this waste material in presence of oxygen and in presence of some fertilizers. Why we are using this fertilizer? Because the fertilizer like the DAP, diammonium phosphate, this fertilizer is very much responsible for the growth of such types of microbes. So we use this fertilizer in this contaminate water. So these microbes, they decompose this waste material and convert into a harmless substances. So these practices known as the bioremediation practices. With the help of some microbes, we can reduce the impurity from the effluent or the contaminated water. In addition, some another practices, this one is the phytoremediation practices. The phytoremediation practices, generally we use some plants, and these plants are generally aquatic plants, and these aquatic plants have a good quality and a natural quality to reduce the waste from the water. Same as the phyto extraction. This technique is also allowed to remove the contamination like the organic matter as well as the heavy metal from the soil as well as the water bodies. The example is water hyacinth. Water hyacinth, in next slide you can see the picture of this water hyacinth. Second technique is the phytodegradation. In this method we use some plants, and these plants produce some enzymes in root zone, and these enzymes functioning as a catalyst for the xenobiotic and increase the degradation reaction. So ultimately the phytodegradation practices, some plants have a good quality to reduce the impurities from the water bodies, and their roots, they provide some enzymes, and these enzymes functioning just like as a catalyst. So in this enzyme, so the process of water filtration become increased. So this practice is also known as the phytodegradation, and some plants generally is used in this phytodegradation practices. These are the Azolla folliculitis species, which are very much responsible for the water treatment or the water purification. So these are the figure of this picture of this Azolla folliculitis species. We can spread it on the water bodies, or sometimes these species are available near about the water bodies where you can see the water is polluted or the effluents are available in the water bodies. Now here you can see some pictures which are picture of some plants which are very much helpful to reduce the water impurities. Here you can see in first slide is the pigweed. This one is the common name is the cholai. So cholai is also helpful to reduce the water impurities from the water. Same as the water hyacinths. This one is the jalkumbi. Common name is jalkumbi, which one is also another plant which what is very much helpful to reduce the impurities from the water bodies. So we can see that these are the some practices like the general awareness as well as industrial technical method, primary, secondary and tertiary treatment methods, as well as some bioremediation practices which are very much helpful to reduce the water impurities or the water treatment practices. So it is requested to all of the students that if you find these plant species, you can cultivate nearby the area where you see that the water is polluted, like the nearby the drain also, open drains also. So you can cultivate such types of plants. By these practices we can reduce the impurities to enter into the nearest water bodies. Thank you very much.